You are welcome back. So we already know that the solution of a quadratic equation that is in this form, ax squared plus bx plus c is equal to 0. The solution is x is equal to, that is the roots of that equation, is equal to x is equal to minus b plus or minus square root of b squared minus 4ac everything over 2a. So from here, let's represent the b squared minus 4ac to be equal to d. So now this d, we can put 3 restrictions on d. That is, we can say that when d is greater than 0, we want to know what will happen to the roots, and when d is less than 0, and c when d is equal to 0. Now let's take them one after the other. So when d is greater than 0, that is when d is positive. When d is greater than 0, that is when b squared minus 4ac is greater than 0. What will happen to the roots of the quadratic equation? Now the roots of the quadratic equation when the b squared minus 4ac is greater than 0, the roots are going to be real and distinct. So the roots are real. The two roots are real and distinct. That is, it is not imaginary, it is not complex. The roots are not complex number. Now, and what will happen to the graph? The graph of ax squared, plus bx plus c is equal to 0 when d is greater than 0, it's going to touch the axis on both sides. So, and we have discussed that the graph of quadratic equation is known as parabola, and it's in form of U shape. So if this form, when d is greater than 0, let's say we want to draw the graph like this. Here is the y-axis, and here is the positive x-axis. Now here is the center. So if you draw a quadratic equation on the graph, it's going to give us like this one, U shape. It's either it looks up or it looks down. And this place, when it looks up, the side, minimum side here is the minimum point. I've made video on that one, so I'll leave the link in the description box. And this minimum point occurs when x is equal to minus b over 2a. So you have to watch that video. So here, the graph of in this form, when d is greater than 0 and a, we said that for us to determine how the graph of quadratic equation looks, it depends on what happens to a, the coefficient of x squared. So when a is greater than 0, the U shape looks up. So when it's less than 0, it looks down. And when it looks up, it has minimum points. When it looks down, it has maximum points. So now here, d is also greater than 0. A is also greater than 0. So it joins or it touches the x-axis at 2 points. So the roots are real, and distinct. So, or the graph can look like this. So the U shape looks down. So here, that means a is less than 0 and d is greater than 0, means that it touches the x-axis at 2 points. touches the x-axis at 2 points. So the roots, nature of roots here, the two roots are real number and distinct. So B, when D is less than 0. When D is less than 0, the root of that quadratic equation is going to be an imaginary root. Imaginary or complex number. And it's not going to touch the graph at all. So maybe it's like this. So if you see any graph that looks like this, you should know that the D is less than 0. It's less than 0. So see, when D is equal to 0. So this time around is when you want to determine whether this quadratic equation is a perfect square. They ask you to find maybe K or R or something. We have done video on that one also. They ask you to find, to determine the value of K or R for that quadratic equation to be a perfect square. So that is when D is equal to 0. So now, for this time now, the roots, nature of roots here are real and equal. So we call the roots to be coincidental. So it touches the axis at just 1 point. So it's a rough sketch. So that means D is equal to 0. So the nature of roots here is that the roots are real number and equal. So we solve example on it for you to understand it. So or it may just look like this, may look up. So it must touch it at just 1 point. It will not cut the axis, but it just touches it at just 1 point. So that means D is equal to 0. And the nature of roots are real and equal number, the real number. So let's solve example for us to understand it better. Since D enables us to know the position of graph of quadratic function and it enables us to know the nature of roots, so it is called a discriminant. Example, determine the nature of roots of the following quadratic equations. 1, x squared minus 3x minus 2 is equal to 0. 2, x squared minus 6x plus 9 is equal to 0. 3, 2x squared minus 2x plus 5 is equal to 0. So we want to determine the nature of the root of this quadratic equation. Solution. So for the first one, which is x squared minus 3x minus 2 is equal to 0. And to determine the nature of graph, now we need to find the value of A, B, and C. So here A is equal to 1, B is equal to minus 3, and C is equal to minus 2. And we need B squared minus 4AC, which is the discriminant. So for us to know whether it is greater than 0 or less than 0 or equal to 0, that is what we want to determine now. So anywhere we see this one, we need to substitute the value of A, B, and C. So B here is minus 3. So minus 3 squared minus 4 multiplied by 1 multiplied by minus 2. So minus 3 squared is 9. Minus 4 multiplied by 1 minus 4. Minus 4 multiplied by minus 2 plus 8. So plus 8. So is equal to 17. So here 17 is greater than 0. So the nature of roots of this one will be distinct. The roots are real and distinct. Since the discriminant is greater than 0. 2 x squared minus 6x plus 9 is equal to 0. A is equal to 1, B is equal to minus 6, and C is equal to 9. So b squared minus 4ac discriminant is equal to b is minus 6 squared minus 4 multiplied by 1, that is a, multiplied by 9. So minus 6 squared is 36, then minus 4 multiplied by 9 minus 4, minus 4 multiplied by 9 minus 36 minus 36. So that means the discriminant b squared minus 4ac is equal to 0. So the nature of roots when discriminant is equal to 0 is that the roots are going to be real and equal. The nature of roots when d is equal to 0 are real and equal. 3. 2x squared minus 2x plus 5 is equal to 0. So a is equal to 2, b is equal to minus 2, c is equal to 5. So b squared minus 4ac is equal to minus 2 squared minus 4 multiplied by 2 multiplied by 5. So minus 2 squared is 4, minus 2 multiplied by 2, 8, minus 8 multiplied by 5, that is minus 40. Minus 40. So 4 minus 40 is minus 36. Minus 36. So the discriminant is less than 0. So the nature of roots when d is less than 0 are imaginary number. So the roots are imaginary or complex. And its graph will not touch the axis at all. So that is that.